In this tutorial, we are going to learn how to calculate the distance to the voltage minima and voltage maxima with the help of an example. If you see a Smith chart, you can see that on the leftmost point, the value of R is 0, the value of X is 0, and so Z is equal to R plus JX, which will also be equal to 0. So if the value of Z is equal to 0, we call such a point as a short circuit point. And as you all know, for a short circuit, the voltage value is minimum, or it is equal to 0. Now if you go to the rightmost point, the value of R is infinity and the value of X is infinity. That means Z is also infinity. If the impedance value is infinity, you call it as an open circuit. And as we know, the voltage is maximum at an open circuit. So we need this idea to learn how to calculate the voltage minimum and voltage maximum. Now what do you mean by L max and L minimum? L maximum is the distance from the load to the maxima, and L minimum is distance from the load to the minima. That means to calculate L maximum, you have to calculate the distance from the load to the voltage maximum, and to calculate the L minimum, you have to calculate the distance from the load to the voltage minimum. Now we will see an example to calculate the voltage minima distance and the voltage maxima distance, which is L maximum and L minimum. So this is a transmission line circuit where we have a source connected to a load which is 70 plus j60 ohm through a transmission line which is 100 ohm characteristic impedance. So the first step is we will normalize the value. So we have ZL is equal to 70 plus j60 divided by 100, which will give you 0.7 plus j 0.6. So if you see, this is your 0.7 value and this is your 0.6. So they meet here, and that is your ZL. After plotting ZL, we will draw the VSWR circle. Now we can see that when we draw a straight line from the center of the circle, so this is your ZL. If you draw a straight line through the ZL from the center of the circle, you will get the lambda of ZL. So here you can see that the lambda of ZL is equal to 0.114 lambda. Let us now find the first L maximum. Now first L maximum means the distance from the load. So this is the position of the load, the distance from the load to the first voltage maximum when you move clockwise. So you have already seen that your voltage maximum happens here. This is your Vmax. So first L maximum means the distance from the load to your first maximum. So that means this distance is called as first L maximum. So if you see this, the initial point is the load, the final point is your V maximum. So first, and the lambda of V maximum is equal to 0.25 lambda if you see the scale. So first L maximum is equal to lambda of V maximum minus lambda of ZL. So that is equal to 0.25 lambda minus 0.114 lambda, which is equal to 0.136 lambda. So first L maximum means the distance from the load to the first voltage maximum. Suppose the question is to find out second L maximum. Then from the load you will move clockwise, you will reach the first maximum, you keep on moving clockwise and you come back here. That means This is your first L maximum, then you take one full circle and then come back here. So that means it is first L maximum plus, as you all know, one full circle is 0.5 lambda. So here it will be 0.136 lambda plus 0.5 lambda will be equal to 0.636 lambda. Similarly, if I ask you to find out third L maximum, it will be second L max plus zero point 0.5 lambda and so on. So this is how we find out the distance of maxima from the load. So depending on first, second or third or fourth, you have to substitute, keep on adding the values of 0.5. Next we will learn how to calculate L minimum. So this was our ZL. This was our ZL and this was your lambda of ZL, which is equal to 0.114 lambda. Now as you know, this point is going to be your V minimum. Okay. V minimum is equal to 0 lambda. So if I have to find out the distance of first L minimum, I have to calculate the distance from the load to the first minimum. So I will always move clockwise. So from the first minimum, I will move from the load, I will move clockwise till the first minimum. So from the load, which is at 0.114 lambda, I will start moving clockwise. I will start moving clockwise till I reach my V minimum. So how do I calculate L minimum? L minimum is calculated as lambda of V minimum minus lambda of ZL. Now if you see here, we have learnt that lambda of V minimum is 0 lambda minus lambda of ZL is 0.114 lambda. Now if you see here, you are subtracting a bigger number from a smaller number. So it is 0 lambda minus 0.114 lambda. And we also know that 0 lambda is equal to 0.5 lambda, because one full circle of a Smith chart is equal to 0.5 lambda. So what I can do now is L minimum is equal to, instead of 0 lambda, I am going to substitute 0.5 lambda minus 0.114 lambda, which is equal to 0.486 lambda. So this is our first L minimum. This is our first L minimum. So from your load, which is 0.114 lambda, you take a full circle, you move clockwise through the circle and you reach the minimum. Always remember that you will move clockwise and you will reach the minimum. Once you take a full circle, this 0 is actually equal to 0.5. So you will take 0.5 minus 0.114 lambda, which will give you 0.486 lambda. Just like that, what we have learned for L maximum, I can find out my second L minimum as first L minimum plus 0.5 lambda, which will be in this case 0.486 lambda plus 0.5 lambda, which will be 0.986 lambda. Similarly, my third L minimum would be second L min plus 0.5 lambda. Another thing that you can find out easily from the L max L min is L maximum is equal to L min plus 0.25 lambda, or L minimum is equal to L max plus 0.25 lambda. This will help you to find out the answers easily also. So this is the way you will calculate minimum and maximum.